Hello, hello. I'm working on multi-threading and a little voxel game prototype to test the engine. I'm going to be multi-threading the world generation. Probably not. There's really no reason to multi-thread the rendering, in my opinion. I'll multi-thread the mesh generation for like the chunks, but the actual like rendering calls, I'll just do those on the main thread probably. Yeah, because right now, this is just like a really rough project. It's not like actually a game or anything. But right now, it's like I generate the whole world when the application starts, and it takes like 20 seconds. So I want to do that in the background thread. So what do we need? I just don't have it on right now. I might turn it on later. I don't have it hooked up. Okay, let's see. Why is it mad? What's it mad about? Condition, closing brace of template definition not found. What does that mean? So true. Bad lighting day. All right, where am I missing a brace? These are there. That's there. I'm confused. Why is it just this function in particular? That's there. That's there. Where is it? Let's just compile, see what happens. Sometimes IntelliSense or whatever, the error reporting just lies. And I think this is a case of the lying IntelliSense. Yeah, see this over here, I'm generating like 1,000 chunks at the application start. So it takes like 20 seconds. It's like generating like 2 billion blocks or something crazy. So I want to multi-thread this. And I've already solved this problem in my other engine, so I'm just kind of copying and pasting that code right now. That's why I was just like modifying code. Now the chunk debug doesn't work anymore. Why is that? Frame rate's not really doing too hot either. I don't know, it's hard to say. I've been programming for a long time, but I also like wasn't very productive for a lot of that time. So it's hard to quantify. Like, I only started using C++ about 2.5 years ago. Yeah, this is like basically pure C++. So this engine doesn't use any libraries except for obviously the graphics APIs. You can't really avoid those. So I have like Vulkan, or I have DirectX and OpenGL right now. And then I do use some libraries for text rendering. Well, they don't actually render the text, they just rasterize the fonts into like a bitmap, and then I use those to render. But like actually creating like the game window and handling like keyboard input, the engine just directly interfaces with like, I guess, the operating system. So like when you run on Windows, I can kind of show this real quick. Yeah, so like for OpenGL here, this is like my graphics backend sort of directory. So this is the OpenGL one. So this is like, this is like the backend to my rendering API. I don't know. I'm terrible at explaining these things. But so each operating system has its own sort of interface with OpenGL. So this is the one for Windows. Like here's the OpenGL init function for Windows. So like you use like WGL. You have to like make a context, I guess. I don't know. I kind of like wrote this stuff one time and then I just like never have to touch it again. But yeah, and then like if you're working on Mac, you'd have to do the same thing for like Mac OS. Mac OS is pretty simple actually. It's just like this function here. But it's kind of annoying because you have to write it with Objective C++ if you want to work with like the Mac OS windowing system. In like Linux would be this. So you use like GLX because Linux uses X Windows. Yeah. And like the same thing for DirectX. So like DirectX is only supported on Windows, so I only have one like folder here, one source file. But like if I have DirectX in it here, I don't know. The long story short is I don't use like a library to handle this. Like other people use like SDL, it's a pretty popular one. And that just sort of does all of this for you. You don't really have to worry about it. And that's kind of like the rational thing to do. There's like no reason to implement it this low level. I just wanted to because I didn't want to include SDL in my engine. I have folders for like Vulkan and Metal here, but I haven't implemented those yet. I just have like empty files. Yeah, and the same thing for like creating like the window here is another example. So like to create the game window, I basically just implemented these for each platform. So like the Windows system, creating a window, just calls like the windows.h when API calls. Yeah, I am procrastinating Vulkan. But yeah, so like on Windows, yeah, you just like call like the Windows when API create Windows function here, and you pass in some parameters, and you get like a window handle back. And then for like Linux, there's a similar sort of thing. You create like an X window, create X window. Mac OS, again, the odd one out, where you have to like use Objective C++, which, hot take, not a very good language. I don't like the syntax of it. It's confusing. Yeah. Like, I don't think any one part of it's that hard. It's just there's like a lot of work to get an engine to like, there's just a lot of systems you need. Because I've been working on this for like 6 months, 7 months, sort of on and off in my free time. And like I still barely have a functioning engine. I just enjoy writing this stuff though, so like I do it for fun. But yeah, definitely not the most efficient way of making a game. Anyway, back to this multi-threading stuff. So I gotta remember how to actually use this. Yeah, no problem. Yeah, like, to go on a bit of a tangent, recently I was getting so fed up with writing shaders for each of the graphics backends that I wrote my own shader language and a compiler for it, so I can just write shaders in like one language and they just, like, I guess cross compile, I don't know the right terminology, transpile into the languages that each of the graphics APIs use. Because like if you're on DirectX, you need to write HLSL shaders. If you're on OpenGL, you need GLSL. So if you're trying to write like sort of a graphics API agnostic rendering layer, Yeah, it's like functional now. It's not done. Like I'm still I don't support all the intrinsic functions yet. I'm just sort of adding them as I need them. Otherwise, I have to like go through and add like 100 functions. But like it has all the fundamental stuff. I can't even think where I am. Like my little voxel game here. These are the shaders for it. So like here's the main shader. It's kind of a gross looking shader right now though. But yeah, it's kind of neat because like this compiles into, well, I'm running DirectX 11 right now, but yeah, this gets compiled into DirectX 11 code or HLSL code. But yeah, back to the multi-threading. So let's see. I'm just gonna test this because I don't even remember how this system worked. Runtime. Just make something here. So let's just print. All right, so in theory, this should create a separate thread. And what was it supposed to return? Oh, it's returning the integer, I think. I don't think that worked. No, I actually didn't. That's kind of funny how this works. So I was too lazy to do that. So I made the syntax compatible with C++. So let me go back. I can show this off. Where am I? Here I am. Asset shaders. Yeah, so I get syntax highlighting. You can see it's like broken here. But I made this compatible with C++. Like if you look down on the right side here. And the way that works is I just have this like header file that I include at the top, which has just like forward declarations for all these like types and keywords. Now this doesn't actually get compiled. This header is replaced with like a blank file when the compiler runs. But that's just so I could like be lazy and not write my own like language server or whatever it's called for the shaders. And it's nice then because then I get like IntelliSense as well. Like I can come in here, like if I want to look at what my global variables are, I can do like globals dot, and I can just see them here. So these are like, I don't know, my perspective matrix. I can F12 to that, and here it is. This is in like a constant buffer. So it's like a shader uniform. Yeah. I did the same thing with like my little object system as well, because that has its own sort of pseudo language that it uses. And I generate C++ code from that for the objects. But yeah, like if I hover over this, you can see it's just a define. Like this is just a pound define to a struct. But the compiler actually parses these keywords and does the appropriate things with them. It's like if I look at what the generated output is for this shader. Let's see. Yeah, so like, let's go to the one with shadow mapping. So the first step it does is it runs a preprocessor on it. So I just run, I think, the GCC preprocessor. And that will just resolve things like removing comments and doing like the macros and like the, I guess, just preprocessor directives. So then this is like the preprocessed file. That also includes like the pound includes, so like you can include files in shaders. And then this is what gets I guess parsed by the compiler and then split up into like the vertex shader and the fragment shader. And these files are actually like, I have these generating here in this like output folder. This file isn't actually used. I spit that directly into the game's binary file, but I just generate these files just so you can actually see what the output looks like if there's like a bug or something. Surprised there's not more in this. Or no, I'm looking at the wrong one. This is the one I want to look at. Yeah, this is a more complicated shader. Yeah, this was kind of tricky to figure out actually, because like each shader language kind of does things in a slightly different way. So like HLSL uses like semantics to figure out like the input layouts and stuff. And like you have to like, if you're writing position, you have to write it to this SV_position semantic. Whereas like OpenGL, you have to like specifically use GL, I think position. Yeah. And like it's kind of annoying because like in HLSL, if you're like doing matrix multiplication, you use like the mul function, but in OpenGL, it's like an overload on the like the little asterisk. This guy. So why didn't this multi-threading thing work? That definitely should have worked. Let's go back to this. Runtime, main, thread create. Does this not run immediately? Oh no, it ran here. Okay, maybe that did work. So let's make the generation thread do something for I haven't actually used the multi-threading in any of my little projects yet, so I'm not sure if it still works. I don't know why it wouldn't. It's like sleep for 1/10 of a second. Yeah, there we go. So now I just need a way of I'm trying to think. Yeah, the tricky thing with multi-threading is you want to avoid like race conditions for like data, I guess, access and reading and writing. Like you don't want two threads writing to the same data at the same time. And I guess that wouldn't happen in this engine because generation well, I guess it could happen. I don't know. Let's just write some stuff. See how it works. So in the chunk, let's just add this in here. So I have a chunk generate function. Chunk generate. And where is that called from? Yeah, so here we can just spin off the chunk generation thread, I guess. just need to move this stuff. All right. Create the thread after I fill the queue, probably. All right, errors, fun. Expected expression. Oh, I see what's going on. Seg fault, love it. All right, let's see why. Where do we error? Fun. Oh, I got an actual compile error this time. Oh, LLVM doesn't have address sanitizer. So we errored in interesting. Why do we error there? Let's see. So it doesn't like this. Oh, that's fine. Doesn't like that. That's fine. Doesn't like this. So the error wasn't where it said it was. Let's see. Let's create something else then. Let's make like an intermediate thing. Oh, I see what's going on. I think I'm getting a dangling pointer problem. Pointer invalidation, because this list could grow. I don't think it should though. Well, I guess it would, yeah. It definitely would. So let's just make this bigger. Alright, so I think we have a different error now. A global buffer overflow. It's like the best kind. So where is it hitting that? It's hitting that here. Let's see. So it doesn't like this function? Is that the problem? Yeah. Let's at least print. See what it does. Chunk. I should at least expect like 1,000 of these things. Yeah, there we go. It's a good sign. I don't know if that's 1,000 though. Might be. But it doesn't like the generation part of that. So are these pointers just bad, maybe? Yeah, these are just bad pointers. Look at these. Null pointers. But it's checking this. Oh, I'm setting it. Oh, that makes sense. There we go. So now, I think this should just work. Let's see. Oh, not yet. So what's the problem now? Doesn't like this still. Fascinating. Heap use after free. How is that possible? Yeah, I mean, I've written stuff like this before. So, I don't know. I've definitely had my Googling phase. I've been making block games for a while. I'm kind of embarrassing myself with these memory problems though on stream. But I will clarify that this project is not like a proper game. This is not good code at all. Don't read this code and get inspiration because it's a patchwork. I'm kind of prototyping ideas here. I think if I did turn this into a game, I'm gonna rewrite it, and I might even start that today. I don't know. It's just kind of a shame because there's so many voxel games. It's hard to stand out. They're just so fun to make. Alright, so what's the problem? I thought these pointers were fine. Let's go back. Let's print. See which one. Maybe it's failing on like a specific one. Attempting to generate. All right, let's see. It's failing on the literal first one. Okay. So why would it be failing there? It's failing here, I think. These lines. So it's like memory alloc is failing. I'm not sure why that would be. Interpret cast. It's like this doesn't point to something. It's like I'm pointing to something that doesn't exist, which is weird. What if I do that from the main thread? Let's see. So rather than doing this, let's just chunk.generate. Does this work? Okay, this works. So yeah, it doesn't like... Is it because this thing's a reference, maybe? It's like a reference to... That should be fine. Man, that is slow, isn't it? I wonder if I'm like infinite looping. Chunk size. Generate. It's as if it's like not removing it from the queue or something. Let's just see. So what is this doing? So that adds the chunk and then we attempt to generate it. So this should be in here twice. It's not. Fascinating. Truly fascinating. No, that would be in there twice. I just have too many chunks. Let's make the world smaller. Let's make the world like 1 by 1. 2 by 2. So we add the chunk and then we try to generate the chunk. And then it fails because for some reason the chunk doesn't exist or something. This thing should be null pointer. Okay, so this thing just doesn't exist. Heap use after free. So like this, is this list growing? Let's just use something that doesn't grow. Let's allocate, instead of having, let's just do this as a test. We have a chunk buffer. So we will instead just do this. So chunk equals chunk buffer I times j. This might actually not work because let's just do this. This is like the most gross code I've ever written. All right. Chunk index. Why is that not happy? All right, let's try this. Okay, getting a bit closer. resource equals null pointer. So that was an init. No, generate. I see. We need to zero this. Man, it just does not like this. Access violation on unknown address F. Let's run this with the debugger instead. Okay, it does not like the debugger. Or wait, am I at a breakpoint somewhere? No? Oh, here we go. It's just mad. All right. Look at this. Okay, so it works sometimes, and then it just crashes. Oh, that should definitely work. I'm surprised. All right, let's delete this. Well, I guess it's because I need that chunks list. Yeah, so I can't actually remove that. This. So let's remove this. So I think I already see the problem though. It was this. This is supposed to be like this. There we go. I always have to figure out why the frame rate is completely locked up. Let's see. Is it a memory problem? No, it's just still erroring. This is why I hate multi-threading. Like I can be like guaranteed there's just a race condition going on. And like the stupid thing with multi-threading is the compiler likes to rearrange code kind of underneath you. So like you'll read code here that's like, oh yeah, logically this should happen before that. But if the compiler doesn't know your intent with like I guess multi-threading it can rearrange the order of things if there's like some optimization. So the way you're supposed to get around that is by using like memory fences, or like a mutex kind of does that inherently. Like the compiler will see that and be like, oh yeah, you're actually probably doing something that we can't rearrange. And obviously I'm just like hacking this together right now, so that's not something I'm doing. So for all I know, it could just be like rearranging something here. But I'm not sure. Because like this worked one time. See, it works now, which is fine. It's not rendering anything though, just completely frozen. It tells me it's not working correctly. But sometimes it crashes. So let's see. Is this function correct? Unlock. Yeah, here we go. It just crashes here. And like this is just some random error, which tells me that it's writing to something. It's like writing to a bad address and just corrupting the the state of the program. Because nowhere in that function am I creating a shader resource view. Right. So it's definitely this it doesn't like. Let's see if we should maybe in the generation queue. The weird thing is that these pointers are correct. Like the main thread's adding this pointer, this pointer, this pointer, this pointer, which point to a chunk, and like the size looks about correct. Like these seem like a reasonable offset for the amount of data I have on a chunk. And then the generation thread is working its way through the queue and calling the generate function on that pointer, which, I mean, should exist. Let's see how far it gets. Data. Let's see. Like this should work too. I'm stuck in the game right now. I guess what could be happening is the this could be a D3D11 problem actually. Because I'm calling D3D11 functions on a separate thread, which maybe I have to enable that. Which I think is like up here somewhere. This. I think I remember reading this. Yeah, here we go. Prevent single threaded. But I don't have this on, do I? Yeah, so I don't actually have this enabled, so that should be fine. Oh no, I do have it enabled. Let's turn this off. Let's see what happens. Okay, that seems to be the problem. There we go. This whole time, I'm fighting multi-threading. And the problem was DirectX 11. That's so fun. All right, let's put a to-do around this. Fix this. The most helpful to-do ever. And let's go back and make the world big again so we can see what that looks like. Chunks. See, now the world's generating, which is kind of cool. Look how slow it is. Now I think that's because I'm sleeping in the generation thread, so let's turn that off. Like this probably shouldn't sleep. I don't know. No, that's not it. Stop printing. Seems like it's way slower than it should be. Oh, I'm in address sanitizer build. Obviously, it's gonna be slow. Alright, let's put this in a release build. Oh, shoot. We have a seg fault. Why? Okay. Uh-oh. Is it because of the... Yeah, there we go. That's a lot. That's more like it. Now we can be even more clever about this. We could sort the draw list. So that we try to generate chunks that are closest to the camera. Shadows don't work either. Yeah, so let's sort the generation chunks. So I don't actually, I was just thinking about this. I don't actually need a thread safe queue for this with the current implementation. So I'm actually going to remove that for now. I guess it'd be faster to move this off the back. So this should functionally do the same thing pretty much. And we can have a quick sort. I'm working on, well, I'm just kind of like playing around. I'm making a little voxel game, voxel rendering engine. I can show it in a second. I just have to get these functions implemented. just do this. Oh, quick sort. What do I call this? Okay, so it's generating in the reverse order. So it's generating furthest to nearest, which is not the goal. So we have to reverse this. False. Here we go. Now it's generating correctly. Yeah, thanks. Yeah, this project's really just like a, I don't know, a little stress test for the engine. It's like forcing me to get multi-threading to work and like fix up some of the rendering stuff. Chunk generation is pretty slow, isn't it? Let's remove this and remove these. This works fine. So I want to time this. How does it not know what that is? This. No, I just compile them. I wouldn't even say compile. I just, they translate into, oh, I just segfaulted. Oh no, I didn't segfault. What happened? No, I just generate like HLSL code or GLSL. Because like HLSL or GLSL can't be compiled into bytecode. So yeah, that's just not the problem I was trying to solve with that. The problem I was trying to solve was just not at writing like three different copies of the same shader for every graphics backend. Because like when you're writing a game, that's the last thing you want to do. I don't want to be like sitting here writing and maintaining several permutations of the same exact shader. It's easier to just write it once. Oh, that's what just happened. So let's see. It was when the chunk ran out. The size got too big. So if size is greater than 0. Not sure why that happened. So it's when the world finished generating, it crashed. Boom. Why would it do that? Oh, it's because I'm trying to sort when there isn't anything to be sorted. There we go. All right. It's pretty satisfying just seeing this kind of work. Still seems really slow to me though. It's like taking 20 milliseconds to generate a chunk. I mean, it's not bad, but that's still not great. So let's see. What's the slowest part of this? I mean, I guess it is writing like 4 different meshes. It'd be hilarious if I'm not even writing in order of like memory. Yeah, I mean, like I'm not I'm not that good at writing compilers, so like I wouldn't even trust myself to write good bytecode. All right, this is let's see, am I even writing memory in the correct order? Let's print out the indices. Because it could very well be the case that I'm just like writing in the worst order possible here for like cache. Let's see. Ideally, these should increment like by 1 value each. All right, let's see. Ooh, it's not what I like to see. All right, so this is probably part of the reason why my chunk generation is super slow. Every time I write a block, this is like the index into the array that I'm writing to. They're jumping up by like several thousand each. I mean, I guess this should be predictable by the CPU, right? These seem to be like a constant interval, but not ideal, not ideal. So let's fix this. If we just do X and Y, what does that look like? Oh, how is this getting packed? I don't remember. So we should loop X should be the inner loop, Y should be the middle loop. So if we just swap these, like Z, and then X would be the outer loop. And then I think I need to, oh, that might be fine actually. Let's go back. X outer loop. Let's print this again. There we go. Looks a bit better. These are incrementing by 1 each right. So let's see what this looks like now. Yeah, there we go. See, just that small change. Look at that. Just that small change almost halved the time. Some of these chunks are pretty slow, but like it was about 20 milliseconds before. So maybe like a 30 to 40% increase. This seems to be about 12. Just by aligning the writes such that they align with cache. It's funny how big of a deal that is. But we're not done yet. Let's see, what else can we do? Maybe that's the best we can do. So it's about, maybe it's about like 30%. Let's try MSVC, see which compiles faster. Wow, GCC is slow. Wow, it's like 2 times slower. With do I have compile? Do I have optimizations turned on for that? Yeah, I have O3. Let's turn debug off for LLVM. I wonder how much of this time is just spent writing to the vertex buffer. There's gonna be some overhead there. Let's see. So let's time each of these stages. Yeah, okay, see. They're about the same, actually. So it's like 6 milliseconds generating. About like 8 or 9 milliseconds meshing, which includes writing to the vertex buffer. I use simplex noise for terrain. So yeah, this part's not cheap at all. It's like the slowest part probably. Like, what is this doing? Simplex sample. It's like running all of this for pretty much every block in the chunk multiple times. I'm sure I could make this more efficient if I like pre-computed a table of simplex noise and then indexed into that, rather than like recomputing simplex noise every single block. Because like really all I use the noise for is just get some like random, I don't know, intervals and then I combine them at different frequencies. So I'm sure there's a lot that could be done with that. Not sure if there's anything else I could do here though. I mean, I could make meshing faster. Maybe. No, I'm not using I'm not using the GPU for terrain. I mean, I guess I could, right? You just probably be great for it. Because every block is just kind of like a function. It's like a simplex. It's like a noise-based deterministic function. What type of block is at what position? So you probably could do that with a shader. Yeah, probably. Well, you'd still need the block data back on the CPU for like collisions and stuff. So well, maybe not actually, thinking about it. Like if you make the entire, like if you make a block entirely deterministic, where you just call a function, give it like an X, Y, and a Z, and then you get a block, I guess you wouldn't actually need to store the block data on the, like in RAM. You could just like compute it every time you need it, probably. It gets a bit more complicated if you have like building though. Like if you're gonna be able to destroy or add to the terrain, you would need to have some way of keeping track of that. Like right now I'm just creating a giant 3D array essentially and storing blocks. And each block is currently 4 bytes. So I have like RGB, like 24 bits for RGB color. And then I have a byte for the block ID. Yeah, and this little engine doesn't have textures. I'm just doing color, kind of like Cube World. I'm also being really inefficient with my vertex or my meshing right now. You can see like I'm generating the seams between chunks, which is like really wasteful. Yeah, it's like really visible here. Why is my frustum culling overlay not drawing anymore? Frustum. It's like none of my overlays are working anymore. Let's see, why is that? Oh, I'm returning here. Okay. Yeah, there's a lot of optimizations I still want to make on this. Again, like I'm not sure if I'm actually to turn this into a game. I'm really just kind of messing around right now. But like this doesn't have, so it has like an LOD system, which is like what this overlay represents. It's probably hard to see on the stream because the bitrate is probably terrible, but like that, like I can like make it really extreme. Oh, like this, you can you probably see this, I bet, if I turn those off. So there's like an LOD, and obviously that just reduces the number of triangles. Let's go into a debug build so we can actually see the stats. It was actually really simple to get it to work. But again, I did it in a very like hacky way. Oh, my microphone's going all weird. 1 second. I think it's working now. Yeah, so the way the LOD works is it basically swaps the LODs when a chunk or when a voxel, like a block, is less than half a pixel wide on screen. So the idea is that like, and that's for the highest quality setting. So the idea is that you shouldn't notice the swaps because it always looks kind of dumb when you can see like the LOD popping off in the distance. So what I try to do is I basically just calculate the chunk bounds in screen space, and then once the I guess the size of a block is less than half a pixel is when it like down I guess, downloads. So you can kind of see where that happens here. So like these pink chunks are the ones that are nearest. So each block here is larger than half a pixel. And then, I mean, the yellow chunks, so like basically it's just rendering it half resolution. So it's just combining every 2 blocks into one. And then it just does that recursively until like some maximum. I set like a limit on it. And then I can change the threshold for that. So that's like the highest setting, is you shouldn't see the LOD pop. But if I make it like extreme here, you can see like where this pop happens on this like little hill here. So I think this is if a block is less than like 4 pixels, I think, or maybe 8 pixels. Is the lowest quality setting. But you can see, maybe not. If I turn the sky off, you can read the debug overlay here. But you can see the difference that makes on the triangles. So like at a pretty big view distance, the highest setting, it's trying to render like 44 million triangles in this view. And that's frustum called too, so as I like move around, you can see the triangle count changes. So like kind of the worst case is if you're like looking like this. No, maybe not. Or here's like a pretty bad case. There's like 90 million triangles being rendered here. So yeah, that's like the LOD system. But one of the problems I have is even with the LOD system, that's still not really good enough, because there's like overhead in draw calls, like just to begin with. So like regardless of the LOD, right now my chunk system doesn't like batch the chunks. So like regardless of the LOD, it's still doing like 1,000 draw calls. So every chunk is its own draw call. And I did some profiling on this yesterday actually, and at least on my computer, the draw calls are the bottleneck here. So like I'm getting about 200 FPS. Let me turn the frustum culling back on. But it's not actually the time spent rendering the triangles. It's the time spent, I guess, submitting draw calls, which is actually bottlenecking my frame rate on my computer. So ideally what I would do is, I guess, batch these chunks, these faraway chunks, into like single calls rather than like submitting each call individually. So the way that's typically done is by using an octtree data structure, where basically like you LOD using this octtree instead of having each chunk its own thing. So when I rewrite this, if I rewrite this, I'm gonna implement that, because that'll drastically reduce the draw calls too, which is kind of a bigger deal. And then the other thing I want to do as well, I'm not sure about this yet actually though, is a technique called greedy meshing, where maybe I can turn on wireframe mode actually. Draw chunk. Let's turn on wireframe mode here. On the chunks. Yeah, so this is with the wireframe mode on. So you can actually see what the triangles are like here. So like right now, each block is just its own set of like 2 triangles per face. So there's a meshing algorithm called greedy meshing, which basically tries to combine like blocks into single triangles. And that will reduce the triangle count, obviously. And since my engine doesn't have textures, it just has colors, I'm just gonna, I guess, greedy mesh based on color. And for like nearby chunks, it will need to be an exact color match to greedy mesh. But for far away chunks, you can sort of add some bias to that, because the further away it is, I guess the less you would notice colors sort of being combined. And there's distance fog as well. The only reservation I have with doing that, though, is, let me turn this off, is I have shadows implemented in this, and I'm actually computing the shadows on a per vertex basis. So you can see, like, it's like typical shadow mapping with like a shadow map depth buffer, I guess. But it calculates the shadows based on the vertex rather than a pixel shader. And that's just like a stylistic choice that I think looks good in a voxel game. But greedy meshing would interfere with that, because you could have situations where, like, I don't know, rather than having each block sort of have its own shadow line, you would have like these set of blocks that share just two triangles, and then the shadow wouldn't look too good, potentially. But for far away chunks, it's probably fine to do that, because you wouldn't really see the detail in the shadows anyway at a distance. It's just sort of like, is there shadow or not, is what matters. I'm really tempted to write a voxel game. It's just like there's so many of them. They're just so fun to make, though. Like, I really want to make this just because, like, I can. And they look cool. It's like a fun technical challenge. It's like, how do you basically optimize the number of triangles and draw calls while like minimizing the effect on like the visual appearance. Thankfully, voxels are pretty forgiving. What would it look like if it's like snowy? That'd be cool. Let's do it. Let's add snow. Let's turn grass into snow. It's a good color for that. Nice, like blue color. add snow to the top of leaves as well. Generate tree. Sweet. Winter Wonderland. I don't have D3D12 implemented yet. Eventually I'm going to ditch D3D11 and OpenGL for Vulkan, DirectX 12, and Metal. Because there's like some stuff I would like to use. Like draw indirect, I think it's called. Where you can sort of like multi-draw would be really nice. Yeah, well, I work with D3D12 at my job, so I have experience working with it. But yeah, it's a bit harder than DirectX 11. DirectX 11 is easier to get going. It's interesting how the top of the leaves don't draw. Oh, that doesn't work at all. Alright, I think I'm gonna start writing this. again. So let's actually do this the proper way. Let's create a new project. Wait, what?